Welcome to the Fine Print series. Today's topic is about GDI or DI, gasoline direct injection. By the end of this video, you're going to learn about what it is, why it was created, the benefits, the pros and the cons. And if you're an owner of a direct injected car or direct injected motor, you may have some issues with it. And we're going to cover things you can do for preventative maintenance, and then of course, if you have the issue, how you resolve it. So let's take a deep dive into this topic. Now first, you have to understand why direct injection was created. And the primary reasons are fuel economy standards and emissions regulations. Something that did not exist forever ago when the internal combustion engine was created. And that's really the big problem. It was never designed for all these types of control devices, and that's why things have gotten so complicated with the modern motors, and why so many people are bandwagoning the electric car era. Direct injection is going to sound pretty scary, but really all it is when you fill up your fuel tank, your gasoline goes into a fuel tank. There's a pump in the tank that moves it through the hoses all the way through the fuel lines to the front of the car if you have a front engine car, and it moves the fuel all the way to a low pressure fuel line to a high pressure fuel pump. This pump is cam driven. It charges the fuel along these fuel lines, down the rails, down the lines, into the injectors. And here is where the fuel is delivered, into a direct injector. It's called direct injection because the fuel injector is sprayed directly into the combustion chamber. There's your spark plug, there's your fuel, and that's what causes the combustion process. These are your intake valves that open and close, that is your piston, and that is the combustion cycle. So direct injection, or GDI, is nothing more than an injector being sprayed into a cylinder. Now, there are different ways to deliver fuel electronically. Before direct injection, really what the mainstream is right now still with most cars on the road is PFI, or port fuel injection. So let's take a look at how port injection works versus direct injection. Port injection, much like direct injection, you fill up your tank, there's a fuel pump that sends fuel through the fuel lines to the front of the car, assuming your engine's there, directly to a fuel rail, and the fuel rail will distribute fuel to the port injectors, which then spray into the cylinder head. But this time, instead of spraying directly into the cylinder, you're spraying on the back side of the valve train through the openings of the valve ports into the cylinder that way. So there is fuel constantly being sprayed on the backside of these valves. There is no injection into the cylinder directly. And you can see the way that the fuel flows here. Also, you do not have a high pressure system that's cam actuated to build it up. So you only have one fuel pump for port injected cars, which simplifies the process quite a bit. Now you know what port and direct injection looks like and how it works. There's a third iteration. Now, Toyota has kind of mainstreamed this on their cars, and more vehicles that they have are starting to do this. Now, Ford is also starting to mainstream this on their cars and moving away from direct injection only. Now, of course, it's not going to be on every motor because there's a lot of cost associated with it, but this is when you combine port and direct injection. You have a port injector here that sprays into the cylinder head, and you can see that it sprays onto the back side of the valves. This is where the fuel is going. And then you also have direct injection here, which sprays into the cylinder directly. Now, every single manufacturer is going to tell you how their engine design is better than the other guy, how they've done this and done that. Well, really, that's great until you're an owner stuck with the car out of warranty and you have to deal with all the crap. So I'm going to discuss some of the pros and cons and what they've been able to do with direct injection that is really impressive, and some of the things that just flat out suck. Now it's time to talk a little bit more about how this works and the advantages of direct injection. And this is a 3D model by Hyundai for their direct injected motors. Now, let's go back to how this works a little bit. You have low pressure fuel coming from the fuel tank pump into this high pressure module that is cam driven. As the cam lobe spins this, it creates high pressure fuel down the high pressure line all the way to the direct injectors. Now you need high pressure fuel because you're spraying it into a cylinder. These injectors are very high tech, much more expensive than port injectors themselves, because they need to be able to stand to a high temperature, a higher flow rate, and of course, well, they're inside the cylinder. So this fueling technology combined with modern ECUs or computers in cars have allowed manufacturers to do things they couldn't do before. Much like your smartphone, you used to have to walk around with a laptop or have a desktop computer. Car computers are so fast now that they're able to control specific areas of the combustion process. And that's what this is all about. Putting a fuel injector inside the cylinder allows them to either create more power or to burn fuel more completely. There's less wasted. They can use less fuel. And obviously, the huge thing here is it can lower temperatures of cylinders. It can create more power and torque. And alternatively, they can change the modes by changing the way that the valves are operated. They can change valve overlapped when the intake valves open and close based on your cam phasers that can infinitely adjust. And all of this computer control of this requires something like direct injection. Without having the specific control of your fuel in the cylinder, they couldn't do all these things to give you the fuel economy and the power, trying to create the best of both worlds. Now, if you didn't remember, your port-injected motors, which I'm going to show you again, have fuel injectors that spray on the backside of the valves, which have a natural cleaning effect. It creates the spark in the fuel and the upper part of the head or the motor. With direct injection, you don't have that. The fuel is isolated from the valves and only sprays into the cylinder itself. Now, with both port-injected and direct-injected motors, it really is the same. You have your pistons with rings, and what you have is a natural side effect of the combustion process is what's called blow-by. And as this piston moves up and down, you can have unburned fuel and oil vapor that can blow past these rings and back up into the headspace or the crankcase of the car. This happens with direct and port injection because you have pressure that comes up. It's just natural for some cars, and some cars it's worse. It just depends on what type of motor you have. No motor is the same. But so what both cars do as a strategy is, as that pressure moves up, they need a way to ventilate it out, and that's what you call a PCV system. And that crankcase ventilation system has a port on the top up here that will ventilate that unburned fuel, that oil vapor, that pressure, so it doesn't build up in the upper part of the motor. And what it does as a part of the emission system is that PCV system will reroute that unburned fuel and oil vapor back into the intake manifold to be reburned during the combustion process, which on a fuel-injected car, a port fuel-injected car, it's not a big deal, because as that air comes back in here from the intake manifold with that vapor, you have fuel that washes off these valves here. When you have direct injection, as that PCV system is shooting back the oil from the intake manifold back into this valve train here, all that crap is building up on the intake valves, and there's no way to wash it off. And that's one of the primary problems with direct injection. You're not getting the cleaning effect from fuel, and that's why companies like Toyota and Ford are now doing port and direct injection, because you're getting that cleaning effect, and you have even more tuning options with having both. Of course, that leaves you with 2 fuel injectors per each cylinder, but you're getting the best of both, and you're able to do more emissions tricks, more tuning tricks, cooling tricks. So if you just have a direct injected only motor, you're going to have this valve train issue. Now, if you take the intake manifold off and stick a camera down those holes to the intake valves, this is kind of what a port injector car would look like. The valves are extremely clean. Or after a cleaning, of course. This is what intake valves on a direct injected car will look like after 30 to 60,000 miles, depending on the brand, depending on the motor. It's extremely variable, but eventually this is going to happen. The other thing that it can cause, and it's worse on turbocharged direct injected motors, is depending on the manufacturer, the turbos they use, oil can leak past the turbo seals and then get into here as well. So it's like a triple threat. So with no way to wash this off, this is the end game. This is what you're going to have to deal with as an owner of these cars over the long term. And the best part is, and this is the fine print, manufacturers come up with this because they have to follow the regulations. They have to meet these certain numbers. So in a lab, when the motor's new, look at everything it can do. It can be more fuel efficient, you can create more power, it burns cleaner, and then you get it out on the road and you put miles on it and you're stuck with this. Because manufacturers aren't paying to clean these off proactively for you. If you have a DI motor with this problem, depending on where you take it, you're going to pay anywhere from $600 to $1,000 depending on how bad it is. Some cars you have to do this every 30,000 miles. And if you don't do it, well, that's the best part. It's creating the exact problem that it was designed to prevent. Poor fuel efficiency, loss of horsepower. You can have check engine lights, misfires, more emissions created from all of this soot and carbon buildup because these valves cannot operate and open and close properly. You can't get enough air in because the air turbulence is all jacked up in here from all this baked on soot. It's really frustrating, and this is kind of what everybody's pushing as the new thing in modern cars, and this is why we talk about this a lot. Now, before I get into the preventative maintenance side, I want to address this. People ask all the time, how is it that the cars in the 90s and early 2000s and 80s could get 40, 50, 60, 70 miles per gallon? And here's the thing. They were able to do that. In fact, if you took a port-injected motor right now and you ran it lean, like the lean burn motors of the late 90s from Mitsubishi and Honda, you could legitimately get 60, 70, 80 miles per gallon. You might wonder, well, why do you need direct injection? Well, the problem with running port-injected motors lean, and they have done this, is they can't meet emissions regulations anymore. They create too much NOx emissions, which are now, those levels need to be lower and lower. And it requires more emissions control devices, more expensive catalytic converters, EGR, cooled EGR, wideband O2 sensors, all these supplemental things to make sure that, yeah, you're getting great fuel economy, but how do we control the emissions? And that's where it became a losing game. So now you have manufacturers, well, now we can spray fuel directly into the cylinders. We can control the emissions that way. We have a much better strategy at doing that. And I'm just saying this because if you're an engineer or you're a car manufacturer, it's not like they're doing this on purpose. Their hands are tied. They're trying to take something that is totally old school and putting all this new technology in it, hoping to meet all the regulations. And of course, meeting customer expectations, which is like the worst part. We're all a bunch of complainers. So now let's get back into how can you help prevent this? There's not a lot you can do from a manufacturer. If you own a car that has bad blow-by and you have oil seals that are leaky and you're constantly having this issue, well, you're going to be doing a lot of cleanup. So here's a couple things you can do to kind of help prevent it, especially if you're going to keep the car long-term. I stress this enough. You're going to keep it and you're out of warranty. There's a few things you can do. The first thing is oil catch cans, something like this radium can. And it doesn't matter what brand you use. Basically what this does is it runs in between the PCV valve and the intake manifold. And what it's designed to do is to catch and separate the oil and unburned fuel and send back clean air that's filtered back into the intake manifold so you don't get the sludge. And what the nice thing about these catch cans is if you get a good one, you can separate them, you can catch the oil and drain it. You just drain it every time you change the oil. The thing with these catch cans is they need to be sealed because the PCV system is under vacuum. If you screw up the PCV system and you have a leak, a vacuum leak, you're going to affect engine performance because the tuning is designed around having vacuum. If you have a vacuum leak, if you don't use a good can, it's going to affect your idle, your fuel economy, all these other things, and you need to have a baffled can. If it's just an open can, you don't need a pop can. If you put like a tube into a pop can and catch it, it's not going to separate the oil and the unburned fuel from the vapor, and you're just going to blow it right back in. So you need either a scrubber or a baffle inside to separate that air and oil. Now, some manufacturers are putting air oil separators into their PCV system, and it doesn't completely remove all of it. Just like this, it's not going to completely remove all of it, but it's going to remove 95+% of it. The next thing that you can do to help with this is, people talk about using fuel additives. Fuel additives will do nothing for a direct injected car except keep the direct injectors clean. And this is the next thing. You should use fuel additives if you have direct injection, because these injectors are a hell of a lot more sensitive than port injectors, not only because they're exposed to extreme high temperatures, but because they're exposed to a hell of a lot more carbon buildup that can get into the nozzles, that can block them, can affect fuel flow. And if these things aren't blowing clean, then you're losing efficiency. And they're much more sensitive to it than port injectors again. So you might even you really don't want to do this, but if you had a real problem, you could send these out to guys like Toronto Injectors, where they will put these on a bench, spray them clean, like as you can see in these videos. You can see how that they clean the injectors if they're completely clogged. And this is going to become a much bigger issue. And it's a bigger issue with DI. So you're going to want to run injector cleaner more often to keep these bad boys clean. Now you might have noticed a common denominator here. Oil, blow-by through the PCV system, or the oil seals in a turbo. So it makes sense to talk about the oil you use in your car. Specifically, NOAC evaporation loss, or oil volatility testing. The NOAC test is pretty basic. You put oil in a vacuum and you heat it up for a certain amount of time, and you test how much evaporation takes place in the oil based on the percentage. The higher percentage of evaporation, the worse it is for a vehicle like we're talking about. So what do? Well, here's the problem. If you go to a dealership for your oil changes or oil changes in general, your brand or your manufacturer has an oil contract with whoever they put their oil in their car. It could be Castrol, it could be Mobil, Shell, you don't really know. Worse yet, you really don't know what's in the oil. They're not going to publish the oil volatility numbers. So you have to, you have to go out on your own, do the research, and most Group 5s, which are true synthetic oils, will publish their oil volatility percentage. And it seems like through the studies I've read, you want something less than 7% oil evaporation or 7% oil volatility. Again, the lower, the better. Now, here's the other problem. As cars move to 0W20, 0W30, or even thinner than that's coming out, most of those oils have over a 7% volatility. That's because they're thinner. So if you're really concerned about this, specifically if you have a turbocharged direct injected car, then you might want to consider looking at like a 5W or 10 or a heavier weight oil, because statistically, based on my research, most of those oils have a lower volatility rate, less evaporation, and it could help prevent some of these issues. Do your research on it though, don't take my word. The last solution is kind of obvious. You don't buy a direct injected car, you buy a port injected only, or you buy a vehicle with this dual injection, port and direct injection. It just kind of solves this whole thing, but it's more expensive and it's more complicated. Now, if you don't want to run a catch can, a good one, and you don't want to deal with the oil, trying to figure out a better oil to run, then you're left with this walnut shell blasting media, because this is what you're going to be shooting into those intake valves, into that intake manifold through the ports of your engine to clean out the valves every 30 to 60,000 miles to keep it running optimal. You can do the chemical way, you can do the Brillo pad, you can use the drill way, but this is one of the best ways to get the valve train clean again. And this is not something your average consumer is going to be able to do, especially if you have those valves open. You can spray the stuff directly in the cylinder and completely destroy your engine. And this is the sad state of kind of what you're going to have to do to keep this thing running right. So there you have it. You know how port injection works, direct injection, and dual injection, and the benefits that it can bring: better fuel efficiency, more flexibility in controlling emissions. But like any technology implementation, there's some fine print, and now you know it. Take care.